Alright, this is a quick video on the area of triangles, and we're going to use what we already know about the area of parallelograms in order to figure out the formula for the area of a triangle. So we're going to start, like I said, with what we know, the area for a parallelogram, which is base times height. And if we have our parallelogram here, we have a rectangle, we have our base and our height. What's going to happen for our triangle is if we cut this in half, notice we get two triangles. And the base and the height of the rectangle are the same for the base and the height of the triangle. We could forget about this. This isn't really here anymore because we cut it in half. And we just have this triangle here. And it's half of what we started with for the rectangle. So that's how we get our formula for the area of a triangle. You could have one of two things. You could have, literally, the area is 1/2 times the base times the height, because the base times height would be our rectangle, and then we cut the rectangle in half to get the triangle. Another way to do it, and this might be easier for some people, is multiply the base times the height, and then just divide that by 2. It's a little easier because then you don't have to deal with the fraction and type in 0.5 if you don't like decimals to put it in the calculator. This one might be a little easier to use. Multiply the base times height like you would to find the rectangle or any of the parallelograms, and then cut it in half because, like I said before, the triangle is half of the rectangle or half of the parallelogram. Now, there's two vocabulary words. We need to know the base, which is what the triangle sits on. And then you need the altitude, which is a perpendicular line from the highest point to the base. Okay, and we've got three different kinds of triangles, and we're going to label the base and the height, or the base and the altitude in each one of these triangles. Now, the altitude, we are going to think of that as the height in our formula, base times height. It's going to be the vertical line that shows the height. It's got a special name, though. It's called the altitude. So we're going to start with a right triangle. Here's our base, and then we have the height here. Pretty self-explanatory. The height is perpendicular to the base as shown with the right angle. With an obtuse triangle, our base is what it's sitting on, so the base is right here. And the height is actually outside of the triangle, which is okay, because it's from the highest point perpendicular down to the base. That's the altitude. Now, our base needs to be extended a little bit by the dashed line to show that that's where it would be, and we don't count this when we use the base for the formula because it's not actually part of the triangle. We added that there in order to get the height. So we're only going to use this base, and we use this height that's outside of the triangle. For an acute triangle, the altitude is on the inside. So the height is in here, and then the base is all across the bottom there. Pretty self-explanatory. So the easy two, the two that people don't really have much trouble with are the right triangle and the acute, because it's easy to see. The one people usually mess up is the obtuse, because that height's outside of the triangle. So we're going to do 3 examples here. Each one is a little different. The first one, we have a right triangle, and 8 and 8 are our base and our height. So we're going to multiply 8 times 8, and we're going to divide that by 2. Well, 8 times 8 is 64. Divide that by 2, we end up getting 32. And we need to put a label on it, just like we put a label on when we did the area of a parallelogram. So this is 32 inches squared. Again, area is squared because we're multiplying 2 lengths, or 2 dimensions, a length and a width, or base and a height, in order to get the amount of space that the figure takes up. So we end up getting 32 inches squared. Let's look at the second example here. We have a base of 7, which again only goes between these 2 lines. It does not include this dotted part outside. And then we have a height of 5. So we're going to multiply 7 times 5. We're going to divide that by 2. 7 times 5 is 35. We divide that by 2. We get 35 over 2, which ends up being 17.5. And our label is centimeters, so centimeters squared. Finally, we have a triangle. Now, this triangle is a little bit flipped on its head. If you notice, your height isn't sitting straight up and down. It's not a vertical line. It's a slanted line, but it is still perpendicular to what we would call the base, where we have that value. So if we wanted, we could redraw this triangle, and you can if you need to so that you can see it. Here's where our height would be, which is 3, and then our base would be 10. So we have just rotated it counterclockwise in order to get it to sit that way. So we're just going to fill in what we know. We know the base and the height are 10 and 3. We're going to multiply those together and divide by 2. Well, 3 times 10 is 30. Divided by 2 would be 15. And this doesn't have a label, so we leave it generic and we say units squared. And that would be the answer to that problem. So pretty self-explanatory. You just multiply the base and the height and you divide it by 2. Few tricky things though, especially with the obtuse triangle where you have the height outside, or like this last example we did where you have to maybe rotate the triangle in order to see the base and the height. So keep that in mind as you do this, because the math part is pretty simple, but you're going to have to think a little bit in order to find those base and those heights.